Hello, we're back here. This is Calculus 12, Mr. Abbott here, and we are going to look at limits. And so this seminar is all about limits. So, what are limits? Well, mathematicians, just like children, like to see what happens when we push limits. We are told not to divide by zero, so the temptation overwhelms us to see what happens when we divide by almost zero. The process of using almost a number underlines the concept of a limit. So let's look at a function and let's look at this. So let's say the function, oops, let's say the function is x squared minus x divides by x. Okay, to graph this function and to see what a limit is here, when we look at this function, we know that x cannot equal 0. Because if we have a 0 in the bottom, we know a number divided by 0 is undefined. So what's going on here with limits? So let's simplify this. So let's factor out an x on the top. And this will help us graph the function. So now we can take this off. So really the function we are graphing is x minus 1. Okay, so we can graph that. So we know our y-intercept is -1. And the slope is up 1 over 1. Okay, so there's a sketch of that function. All right, but we know that something's going on here because we set up here that x cannot equal 0. So I'm going to put in a hole right here because we know there's an asymptote, a vertical asymptote right there. So at that spot right there in the graph, I know we can't have a value. Okay, so let's see what happens when we get almost to 0. Really, really close to 0. So let's pick a number. Okay, let's pick a number. Let's pick x equals negative 0.001. So that's super close coming to 0 on the negative side, the left side. Well, our output, if we type that into the function, if we put that up into here, all right, we get an output of negative 1.001. Okay? Because we know if we put 0 in, we will get undefined, but I'm getting something close to 0. So let's pick another number on the other side going this way. So let's pick x equals, let's try 0.001. So that's super close coming from the right side. And the output, when we type that in, we get a value of negative 0.999. So you can see, what are we approaching? If we look at these two numbers, this is what limits are about. What are we approaching? Okay, so as you look at that, to me, we are approaching negative 1. All right, so if I wrote this into a limit question, so let's make this into a limit question. So the limit as x is approaching 0 of this function, we know the answer is negative 1. So that's what limits are about. They tell us what we're getting close to. All right, let's look at some other examples here. So first of all, let's graph this function right here. So we go minus 4 is the y-intercept and the slope is 1. So we go up. And so we have a graph. Now let's make it into a limit question. So let's say the limit as x is approaching, let's pick any number. I'm going to pick 3. As x is approaching 3 of this function, what is our limit? So what's the answer? Okay, so let's just look at this. So let's go walk the line. So remember, we're approaching 3 from this side and from this side. We're trying to get to 3. So when we look on this function, we're getting to that spot right here. So we just come across to the y value, and the answer is -1. All right? So let's look at this example. So we got this function, I'll call f of x. And let's make a limit question. The limit as x is approaching, and let's say in this case 2 of the function. We have a value of what? Okay, so we're approaching 2, so we're coming this way, we're coming this way, and we come across to 7. So as we approach 2, the answer is 7. But you may say, well, Mr. Rabbit, there's a hole there. See, there's a hole there, so you can't get to 7. But with the concept of limits, remember, we're trying to approach 7. We're getting really, really, really close to 7. So if I put numbers like 2 in, I will get undefined. So if x equals 2 into this function, I know y is undefined. But limits, we're picking numbers really close to 2, like that number. Or we pick another number on the other side. So these outputs would be approaching 7. So what is a limit? Well, a limit is the y value, or output, as you approach a specific x value. Okay, so that's the very basics of it. Okay, so let's look at some more examples. So let's make up some limit questions. So here we have a function. So let's say the limit as x is approaching 2 of this function. What is the answer? Well, if you look at this, we're approaching 2 from this side and this side, and we come straight across, and the answer is 4. Okay, look at this one. Well, it's the same function, but we have a hole now. So a point of discontinuity, or there's an asymptote going on. So we know if we put 2 in, we'll get undefined. But remember, limits are what we are approaching. So again, the answer is 4. Because if we put numbers super close to 2, we'll get outputs that are really close to 4. So some more examples. Okay, so we have a function here. We have a hole. The function continues, and the dot is up here, the point. So that's the point. This is the function right here. So let's make a question up. So the limit as x is approaching 3 of this function is h of x. So again, we're on the function. Ignore this. Ignore it. It's just the point. You want to be on the function right here. So you're approaching this way to 3, and you're coming this way to 3. So we come across and the answer is 2. Okay, so let's look at the example on the right. So we have a limit question. Let's say the limit as x is approaching 1 of g of x. What's the answer? Well, here we have a different situation going on, because if we look at this, if we sort of come on the right side of the function here, we're following this path, right? And we get to 1, the answer is 2. So we say the right hand side is 2. All right. And if we come on the left side, approaching 1, so the left hand side is 4. So see how these are not equal? They're not equal. So therefore, the answer to this question is does not exist. So does not exist. Okay, so we'll say DNE. So some of the notation you're going to see in this is this. The limit as x is approaching 1 with a little plus sign up here. That means the right hand side, that positive. We know the answer was 2, right? And as the limit approaches 1 with a little negative sign, that is the left side. We know the answer was 4. So because these do not equal, that's why we have a DNE, does not equal. Okay, so you have to really know those notations, those plus and those minuses. All right, so let's look at a couple more examples. So if I gave a question here, we have the limit as x is approaching 1 of this function g of x. We know the answer does not exist, because we just saw that on the previous question. See how this and this don't equal? And we call that a jump discontinuity. So a jump discontinuity. Okay, the function jumps. And the same thing over here. If I said the limit as x is approaching 1 of this function, again, it does not equal. Now watch out, that guy right there is a point. Nothing to do with the limit, it's just a point on this function.